By late 1943, the Luftwaffe's air defense network was under growing strain. Allied bomber formations were reaching deeper into German airspace, and interception tactics that had once worked near the coast were no longer enough. Fighter units such as Jagdgeschwader 1, JG-26, and JG-11 were reporting new Allied escorts that did not disengage when expected. Operational intelligence summaries compiled at Luftwaffe Reich headquarters recorded the anomaly. Where earlier in the war escort fighters typically withdrew over the Netherlands or the North Sea, new types were remaining overhead well beyond Hanover and Leipzig, sometimes even into central Germany. The distances involved exceeded the known capabilities of the P-47 Thunderbolt and P-38 Lightning. By December, the Luftwaffe's own signals intercepts and pilot debriefs consistently mentioned a third type, a sleek, low-drag fighter identified as the North American P-51 Mustang. Early encounters had been rare, but the pattern was becoming unmistakable. The new model appeared to combine high-altitude performance with unusually long range, an unprecedented combination in a single-engine aircraft. On several occasions during the winter of 1943 to 1944, American fighters were forced down in German territory. One of them, a P-51B Mustang from the 354 fighter group, was recovered in relatively intact condition after a forced landing in northern Germany. Following established procedure, Luftwaffe recovery crews removed ammunition and fuel and transported the airframe to the Central Test and Evaluation Establishment, the Erprobungsstelle Rechlin, located near Lake Müritz. Rechlin's engineers had extensive experience with captured enemy aircraft. They had previously examined British Spitfires and Hurricanes and American B-17 and P-38s. Their task was to measure, document, and analyze each component using standardized Luftwaffe test criteria. Upon arrival, the Mustang was logged as Feindflugzeug Type P-51B, motor Packard-5 16503. The engine designation immediately drew attention. The Packard model was a licensed production version of the Rolls-Royce Merlin 61, manufactured in the United States with American tolerances and tooling. For the Rechlin team, this represented an unexpected transatlantic collaboration between British design and American industry, a partnership of precision and scale. Technical officers noted several structural and aerodynamic features that diverged from German design philosophy. The laminar flow wing, for example, featured a thickness distribution shifted rearward, reducing drag in cruise and delaying compressibility effects at high subsonic speeds. The surface finish of the wing, smooth, flush-riveted, and sealed, indicated meticulous attention to aerodynamic cleanliness. The cooling system also differed significantly from German inline installations. The ventral radiator scoop incorporated a controllable exit door, suggesting an attempt to balance cooling requirements and drag. Preliminary airflow analysis confirmed the theoretical potential for Meredith effect thrust recovery, improving efficiency at higher speeds. The Rechlin report detailed a fuel system that combined self-sealing wing tanks, a large fuselage tank behind the cockpit, and fittings for external drop tanks under both wings. Total capacity exceeded that of any contemporary single-engine German fighter. Engineers calculated an operational radius of over 1,500 miles under cruise conditions, roughly triple that of the Bf-109G6. Other features reflected functional design rather than luxury. Standardized control linkages, electrically heated gun receivers, and a cockpit layout optimized for long missions. The instrument arrangement and trim controls reduced pilot workload at altitude, small advantages that accumulated over several hours of flight. The significance of these observations extended beyond engineering. In strategic terms, the Mustang represented a new operational concept, a single-engine escort fighter capable of accompanying heavy bombers to any target in Germany and back to England. For years, the Luftwaffe had relied on geography to constrain Allied air operations. Even the best-planned raids could not be escorted much beyond the Ruhr. By the time the Mustang arrived at Rechlin, that geographic advantage was already eroding. The first long-range escort missions had reached Bremen and Frankfurt, and intelligence officers predicted further penetration toward Berlin. The captured aircraft provided the explanation and the warning. A short note in the Rechlin summary report captured the realization succinctly. The combination of high-altitude power and large fuel capacity in a single-engine aircraft changes the tactical picture. The former safe zone of unescorted bomber operations no longer exists. Once the teardown and ground inspection were complete, the Mustang was reassembled for flight testing. The chosen pilot, Hauptmann Hans-Werner Lerche, had already flown numerous captured Allied types and maintained detailed comparative records. The objective was to validate the technical data with first-hand handling and performance figures. The scheduled trials would measure climb rate, range, maximum speed, and flight characteristics at operational altitudes, the same parameters used to benchmark Luftwaffe production fighters. For the engineers at Rechlin, it was simply another evaluation. For the Luftwaffe command, it would soon become proof that the balance of the air war had shifted beyond recovery. Cold weather and clear skies greeted the first run. Lerche recorded, "Engine start exceptionally smooth, vibration minimal. Throttle response immediate." The Packard-built Merlin idled evenly at low RPM, an unfamiliar calm compared to the rougher idle of the DB-605 in the Bf-109. On takeoff, the aircraft tracked straight, the wide-set undercarriage forgiving to minor corrections. Acceleration impressed the ground crew. The Mustang lifted cleanly after roughly 900 meters, a short roll for a fighter carrying drop-tank plumbing and heavy armament. Climbing through 5,000 meters, Lerche noted the next surprise. The automatic two-stage supercharger transitioned seamlessly. Power did not fall away as it did on the single-stage German units. At 8,000 meters, the Mustang still produced full combat power. Few piston-engined fighters in Europe could match that performance. Leveling at altitude, Lerche pushed the throttle forward and trimmed. The airspeed indicator crept past 700 kilometers per hour, and the engine ran comfortably within limits. Fuel flow, coolant temperature, and manifold pressure were all stable. The laminar flow wing held the aircraft steady with less control input than the FW190A, whose thicker airfoil tended to buffet at similar speeds. When the test pilot landed after his first sortie, the engineers already knew what the numbers meant. A German fighter could intercept a bomber formation near Bremen or Hanover and still return with minimal reserve. This American machine could reach the same altitude, fight, and continue on for hundreds of kilometers more. Over the next 2 weeks, Rechlin conducted comparison flights between the captured P-51B, a Bf-109G6, and an FW-190A8. Each was flown under identical conditions: fuel load, altitude, and climb schedule. The results, summarized in the surviving Technische Bericht 290, were stark. Maximum level speed at 8,000 meters, operational radius with external tanks, climb to 6,000 meters, the data needed no interpretation. The Mustang's range and sustained power gave it freedom of maneuver. Germany's interceptors lacked. Lerche reported that the Mustang could choose when and where to fight. a tactical luxury few pilots in 1944 possessed. In mock engagements against a standard FW-190A, Lerche discovered additional advantages. The American fighter retained energy through turns better than expected. Its elevator authority at high speed remained usable. Compressibility effects, which plagued other aircraft above 600 kilometers per hour, were modest. The aircraft's bubble canopy, fitted to later D models but similar in layout on this B variant, offered superb visibility, a safety factor during the long, fuel-critical missions the Allies were now flying. Gun harmonization and ammunition feeds were equally reliable. 6.50 caliber Brownings with electrically heated receivers could fire without stoppage in sub-zero conditions. German field units had suffered frequent weapon freezes at similar altitudes. The difference between an electric heater and a fuel-air mix mattered at 30,000 feet. Rechlin's engineers admired the detail: the coolant scoop's controllable exit door that balanced airflow and drag, the thermostatically regulated oil cooler, the tidy radio installation that reduced interference between sets. Every feature spoke to iterative testing rather than hurried improvisation. Lerche's flight notes circulated through the Luftwaffe's Technisches Amt, the technical office overseeing aircraft design. Within weeks, a summary landed on the desk of Generalleutnant Adolf Galland, General of Fighters. He understood its implications immediately. The Mustang was not merely a fast enemy. It was the enabling technology behind the 8th Air Force's daylight bombing campaign. For years, German defense strategy had relied on geography. Fighters could intercept over western Germany, engage for 10 minutes, and disengage before fuel ran out. Bombers had to turn back before reaching central targets unescorted. Now, with the P-51, that timetable was shattered. Allied escorts could accompany bombers to Berlin, Leipzig, even Vienna. Every airfield, assembly plant, and refinery that had once lain beyond the practical reach of daylight raids was suddenly exposed. The first field responses were disbelief. Some frontline Gruppenkommandeur insisted the deep penetration escorts must be operating from secret forward bases. Intelligence officers compared times and headings until the geometry proved impossible. The fighters were coming from England, fighting over the heart of Germany, and returning across the Channel with fuel to spare. By spring 1944, the operational evidence matched Rechlin's findings. Losses in interceptor units skyrocketed. Jagdgeschwader 26 reported that half of its encounters now involved long-range escorts. JG-11 near Hanover recorded similar patterns. The myth of German air superiority, once an article of faith, was dissolving in sortie reports. A confidential note from the Luftwaffe's operational staff, dated March 1944, summarized the crisis. Enemy single-engine fighters accompany bomber streams throughout the entire mission. Combat cannot be avoided. Our present fighter types lack the endurance to counter effectively. Even as the front collapsed, German engineers continued their examination. They found that the Mustang's efficiency derived not from a single miracle design, but from integration, a rational match between airframe, engine, and mission. The laminar flow wing reduced drag by approximately 15% in cruise. The radiator duct recovered as much as 90% of the energy lost to cooling drag. The two-stage supercharger maintained near sea-level manifold pressure at bomber altitudes. Each improvement compounded the next. Attempts were made to copy elements of the system. The Te-152 high-altitude fighter adopted a longer wing and pressurized cabin. The Bf-109K gained refined cowlings and extra fuel capacity. None could erase the strategic imbalance that Rechlin's test pilots had already measured. Lerche continued flying captured aircraft until war's end. In his post-war interviews, he spoke of the Mustang without exaggeration. It was not invulnerable. It simply had the combination right: power where needed, range where needed, and no unnecessary complexity. For the Luftwaffe officers reading his reports in 1944, that combination meant something more immediate: the transition from hunter to hunted. Every bomber formation now carried guardians that would not turn back at the frontier. German pilots found themselves diving through layers of escorting fighters before they could reach the bombers, and climbing back through them to escape. By the time Rechlin finished compiling the final charts and flight graphs, the conclusion was beyond argument. The P-51 had removed distance as Germany's shield. Air superiority was shifting not through numbers alone, but through endurance, reliability, and planning. The test flights were complete. The data were logged, signed, and filed. Within weeks, operational commanders would feel the consequences written in those numbers. The enemy's fighters could be anywhere, any time the bombers were in the sky. The 8th Air Force had begun its full-scale daylight offensive. Hundreds of bombers crossed into German airspace, escorted by the very machine that had so recently sat in Rechlin's hangars, the P-51 Mustang. The pattern was unmistakable. Early in the war, German squadrons had launched intercepts knowing their enemy's limits. They could predict when thunderbolts and lightnings would turn for home, then strike the bombers unprotected. Now, the familiar rhythm was gone. German radar stations tracked bomber streams deep into the interior, and the escort blips never peeled away. When Jagdgeschwader 11 scrambled from its bases near Hanover to intercept, the incoming Mustangs were already there, descending from altitude, waiting. Luftwaffe reports from that spring speak not of surprise attacks, but of exhaustion. Crews wrote of diving through layers of Allied fighters to reach the bombers, only to climb back through more of them to escape. The bomber corridor had become a fortified zone, one that moved with the formations, powered by the Mustang's fuel range and the Allies' growing command of the skies. For many German aces, men like Adolf Galland, Walter Dahl, and Johannes Steinhoff, it was a bitter transformation. They had spent years perfecting the art of interception, the short, decisive strike from home airfields. Now, even as they flew the best the Reich could produce, the Bf-109K, the FW-190D-9, and the Me-262 jet, they faced an enemy that had rewritten the rules of endurance. In February 1944, American bombers appeared over Berlin in daylight for the first time, escorted all the way by Mustangs. Reichsmarshal Hermann Göring, once so proud of his Air Force's dominance, looked up from the Reich Chancellery and saw P-51s circling above the capital. He later admitted during Allied interrogation the thought that went through his mind: "When I saw Mustangs over Berlin, I knew the war was lost." That single sentence, recorded in U.S. Strategic Bombing Survey transcripts, captured the turning point. It wasn't the loss of a city or a battle. It was the loss of confidence, the realization that Germany's technical edge had evaporated. What shocked Göring most wasn't that the Allies had built a faster or stronger fighter. It was that they had built enough of them, and built them to last. Every Mustang in the air represented not just one machine, but an industrial process that Germany could no longer match. By late spring, the Luftwaffe's defensive grid was stretched thin. Fuel shortages forced entire squadrons to reduce training hours. Airfields were bombed daily. Even elite units like JG-26 and JG-300 suffered losses faster than replacements could arrive. The Mustang's range allowed the Allies to sweep beyond bomber routes, targeting airfields before the interceptors could even scramble. Strafing attacks by P-51s destroyed hundreds of aircraft on the ground between March and June 1944. Every destroyed hangar or runway was another nail in the Luftwaffe's shrinking operational range. At the same time, the 9th Air Force began using the Mustang for low-level ground attack, further tightening the pressure. For German pilots, the war now began and ended under the Mustang's shadow, before takeoff, during climb-out, and often before landing. A captured German pilot later told his interrogators, "We had no sanctuary. Even our airfields belonged to them." In strategic terms, the Rechlin test results had forecast the inevitable. A single Mustang could remain with a bomber formation for the full mission profile, eliminating the rotation cycles that drained Luftwaffe fuel and manpower. For every German fighter that burned 400 liters of precious aviation fuel on a brief interception, the Allies could sustain multiple long-range sorties on mass-produced 100-octane gasoline shipped from the U.S. in convoys. German industry simply couldn't keep pace. The synthetic fuel plants at Leuna and Pölitz, already bombing targets, couldn't meet the demands of the front line. And without fuel, no new fighter design, not even the Me-262, could restore air superiority. By the time of D-Day, the Allies held near total control of the skies. P-51s flew combat patrols above the beaches, engaging what few German aircraft dared to approach. The Luftwaffe had gone from being the spearhead of German offensives to a defensive fragment, brave, but outnumbered and outproduced. Rechlin itself was bombed several times in 1944 and 1945. Many of its test hangars were destroyed, and with them, irreplaceable aircraft, including the captured P-51 that had revealed so much. When Allied forces entered the facility in the spring of 1945, they found burned files, damaged prototypes, and fragments of technical notes. Yet a few surviving documents made their way to Allied intelligence officers who recognized the depth of analysis behind them. One summary, written in careful German script, read, "The American fighter represents a combination of qualities, range, stability, and serviceability that renders our tactical planning obsolete." For the engineers who had tested it, the Mustang was not merely an enemy weapon. It was an engineering lesson. It demonstrated how industrial cooperation and standardized design could produce performance equal to or greater than bespoke craftsmanship. After the war, several former Rechlin staff members interviewed by the Royal Air Force Technical Intelligence Team remarked that the P-51 had influenced their thinking long after the guns fell silent. They respected it not for its beauty or mystique, but for what it proved. The future belongs to the airplane that can be built in numbers, flown far, and maintained easily. When the war ended, Germany's skies were quiet. The Mustang, once a curiosity on a frozen field, had become a symbol of Allied reach. For those who had studied it, fought it, and watched it change the course of air warfare, it represented more than a technological achievement. It marked the end of an era. Where the Luftwaffe had once believed in short, sharp superiority, the Allies had demonstrated the power of sustained industrial endurance. The Mustang did not win the war by itself, but it ensured that the bombers could reach the factories that would. It erased the boundaries of distance that had once protected the Reich, and in doing so, it ended the Luftwaffe's ability to fight on equal terms. In the burned remains of Rechlin, amid scattered pages and fragments of performance charts, the story was already complete. The sky had changed hands, not through a single battle, but through the simple, relentless truth that range is power. And in that truth, written in the flight data of a captured Mustang, lay the silent acknowledgement of every pilot who had once believed Germany would never lose the air war.